Hello everyone, welcome back to MacTech 40, and today we will see some notes about knock. So what is the knock? So knock is the premature combustion, okay, in a spark ignition engine, and in case of compression ignition, it is a not a combustion, okay, unburnt diesel fuel. We can say that. So that is known as knock. So what knock will do before the actual in knock in spark ignition, or you can say that petrol engine, the knock, it will occur at the end of the power stroke, okay. So what will do, the flame travel, so the like this, the knocking, suppose this is a flame travel due to the combustion in the chamber. So as the flame travels, because it requires some time in seconds, in microseconds, but the flame temperature, flame and the combustible product, whatever the products has been burnt due to this combustion, it has a temperature very high. So and this temperature is such high, such a manner that unburnt products of petrol, this is the fresh mixture of air and fuel, will pre-ignite before this flame reach. So what happened, this flame will travel in this direction and combustion will occur, act on the force on opposite direction. So it will affect our engine performance as well as engine size, sorry, not engine size, as well as engine cylinder inner boundary as well as on piston top surface, okay. So we will discuss what are the factors so that we can reduce the this knocking phenomenon, and we will see each and every detail one by one, because this kind of question that has been asked in gate exam, like 1 marks, what for the to reduce the knocking, what should be the compression ratio, okay. So answer should be low. But in ESC prelims, there are 2 to 3 statements to reduce the knock. The compression ratio should be high. Engine size should be high. So this there will be confusion between this. So we will discuss what are the factors that we can reduce. Okay, so that the opposite will be on to increase the knock, but our try always try to reduce the knock. Okay. So first we will see about petrol engine. So first is self ignition temperature of the fuel. It should be high. So as I explained you, it is burned by the heat released by this combustion product. So if the temperature, the self ignition temperature, that means the temperature at which we can, without any external the flame, it will spark out, okay, the petrol. So the petrol self ignition temperature should be high. Why? Because if the self ignition temperature is low, then if it gets very less amount of heat, then also it can tended to knock the engine, okay. So our self ignition temperature should be high enough, so that, but it should not be high such that the spark is not sufficient to create the combustion, okay. So its self ignition temperature should be high to reduce the knock. Second is compression ratio. Compression ratio should be low. Why compression ratio should be low? Because the if the compression ratio will be high, then in petrol engine, this is we are talking about petrol engine. So what is the inlet, the air fuel mixture? So we know that as the pressure increase, its temperature is also increase for any substance. As the temperature pressure increase, so temperature is also increase. So if we increase the compression ratio such that, because suction stroke in petrol engine, first suction stroke then compression stroke. So what happen, if we increase the compression ratio, so before starting of the spark, before starting of the power stroke, due to high temperature, the fuel will be self ignite and power stroke will perform earlier, okay. So to avoid this kind of situation, we have to low down our compression ratio, but it should not be low down uh, beyond the limit, because if the pressure is very low, then your engine for the same compression your engine side should be bigger. Okay, so we have to optimize that also. Third is inlet temperature and pressure and supercharging. We will discuss this all these two simultaneously. Okay, so what happens? Inlet temperature and pressure. If the inlet temperature and pressure is high, suppose for example if air and air fuel mixture is entering at 27 degrees Celsius, and all the parameters and performance will perform on as per the our standard. Okay, no any faulty operation or no any knock produce all. Okay, standard combustion will happen. But if the temperature will increase from 27 to 40 degrees Celsius, then what happen? Inlet temperature is high, then we will compress, so it may get chance to get self ignite. Okay, though we have a high self ignition temperature fuel. Okay, so there may be a chances that the fuel will be self ignite. Okay, so that's why inlet pressure and temperature should be low, but not beyond particular limit, because if it much more below the limit or practical limit, then what happen? You for same compression, for the same level to achieve the pressure, we have to be uh, apply the more the bigger size. Okay, then supercharging should be avoided, because supercharging, what supercharging does is it increase the density, create the turbulence. Okay, it increase the turbulence so that the all the product will get properly mixed. So as the density increase, then more dense material already in the combustion chamber, then we will apply compression stroke, so it may be chances for the self ignition. So that's why supercharging should be avoided. But if uh, we use the supercharging in between the limits, so that it will increase our efficiency of the engine, so that, so in that case we can use spark advance. What is this spark advance? So we have studied the actual valve timing diagram, that spark is not instantaneous process, because first spark occur, then it propagates and flame propagates, then combustion, it get heat, and the heat it will released to the product, and all this combustion product will take the heat, and then the power stroke occur. Okay, so in that case it will require some time. Okay, so in actual case what happen, the actual spark will always pre-ignite. Okay, the actual spark already occurs before the completion of compression stroke. Okay, to accommodate this time for traveling. Okay, so if we increase the spark advance, so what happens? There may be a chance that the combustible product, the air fuel ratio, air fuel mixture, not ratio, air fuel mixture, it may get pre-ignite. So we have to avoid the spark advance as soon as possible. Flame travel distance, this is the main important thing. The flame travel distance, it should be small. Why? Because if the flame travel distance is long, suppose like this is the top dead center TDC, and this is the bottom dead center BDC. So if the spark will occur, and it has to travel from this to this, but as the spark advances, the air fuel mixture here, it will ignite first. It will it have some higher temperature than the liquid air fuel mixture. Okay, so it will tend to uh, release the heat in this mixture, and the pressure is also high here. As the combustion happen, the pressure is also high, so it will what happen, it will try to come in equilibrium with this lower pressure side in the combustion. So if the flame travel distance is high, so there will be pressure differential will create. Okay, so there will be pressure difference problem also. Okay, and what happened, this pressure difference, before the spark reach actual here, actual combustion will occur, and this will create opposite force on against the spark. So this will be ultimately detonate our engine. So the flame travel distance should be as small as possible. Engine size, Next is engine size. It should be small as much as possible, but not on the compensation of our performance. Okay, because what happen if the engine size is small, so the flame travel distance is less. Okay, so there will be less chance of knocking. Okay, next is turbulence. Turbulence should be high. What happens, why turbulence should be high? Because in turbulent, the velocity of the flow in that case is very much higher than the laminar case. So in case the flame travel distance is long, so the charges get turbulated, so the charge will be flowing here and there in the combustion chamber, so it will ignite the smoothly in whole the region, and the mixture will be work as a homogeneous, not heterogeneous. Okay, so it will be ignite at a time. Next is engine speed. Engine speed should be high. Why engine speed should be high? Because for example 1000 rpm, which is normal to in car engine, 1000 rpm. So 1000 rpm means in 1 minute there is a 1000 revolution of the crankshaft. Okay, so assume so not assume, so when you calculate for revolution per second, so divide by 60. So what happened, 50 by 3, or you can say that 16 or 17 rpm, 17 revolution per second. That means here I am writing rps, it will consume 2 seconds, so almost 34 revolution already completed, complete revolution. That means 17 four stroke cycle already happened. Okay, so as the engine speed is high, so there will be no such time to this flame travel and flame propagation, or this higher compression. So the activities, all these activities, suction, compression, power and exhaust, it will be carried out in very speedy manner, so that will be, we can avoid this knocking. Next is octane rating. Octane rating is what we are giving, the very chemical composition in petrol. There is an isooctane and normal heptane. These two are the petrol is generally mixture of these two. So we are giving the octane rating from 0 to 100. So this indicate the percentage of isooctane in the fuel. So, and isooctane, it is an anti-knock agent. Isooctane, it is anti-knock agent. So as the octane number is high, that means the content of isooctane is high, so it will tend to reduce the knock. So the isooctane rating should be high. So these are the parameters and explanation for the reduce the knocking in spark ignition. Now what happened into compression ignition? So the mechanism compression ignition, that is diesel engine. Okay, so in compression ignition, or you can say that diesel engine, the only air is entering in the suction, and air get compressed, first get sucked and then compressed, and then fuel is injected by fuel injector, and due to the high compression rate, high compressed air, the diesel, as the diesel enter in the small tiny droplets, it gets sparked. Okay, and produce power and perform the power stroke. One more thing, the self ignition temperature of petrol is high compared to diesel. Okay, so what happened if in some case the diesel uh, get admitted through the that fuel injector, but due to less compression ratio, or maybe some other case, the total fuel is not get burned, like this portion is unburned. So as the whole complete process power stroke occurs, then exhaust stroke, so the diesel may get out or may not get out and deposit on the wall of the cylinder, and tend to reduce the our capacity, or in next upcoming cycle it will get mixed and make some small tiny black unburnt diesel, small tiny unburned diesel droplets. Okay, and ultimately it will reduce the our efficiency. So this is known as knocking. And one thing you notice in knocking, there is a one abrupt noise occurring. Okay, and this knocking in spark ignition, or you can say that petrol engine, it will occurring at the end of compression stroke. Okay, sorry, not end of compression, at the end of power stroke, sorry, my mistake, end of power stroke. But in compression ignition, at the beginning of the power stroke occur. So to avoid this, what happened, the compression ratio should be high. Why compression ratio should be high? Because as we increase the compression ratio, so that there is a maximum chance that the temperature will also increase. So there is a chances that all the diesel which is going to inject through the steam fuel injector, so it will get combustion. Okay, self ignition temperature should be low, because in diesel what happen, if you increase the self ignition temperature, then you have to increase the compression ratio. But if you increase the compression ratio and no any spark mechanism is there, so if you increase the self ignition temperature, so you have to increase ultimately compression ratio. So ultimately what happen, engine size get, for the same output your engine size will be larger. Okay, so the self ignition temperature should be low. So that's why in compression, the compressed air, all the diesel will be get compressed. Third is delay period. Delay period should be low. What happened, delay period, that after compression and power stroke, there is some delay between, in between there is some delay between the closing of inlet valve and exhaust valve. So this should be very low, because what happen, if both valves simultaneously open and fuel is also coming, then what happen, air, the compressed air will come here and go out from the nozzle. Okay, I'm drawing here, the fresh air will come, and fuel will also get dropleted here, and both will get trapped out directly without any combustion. So this should be low. The inlet temperature and pressure here, it should be high. It should be very high, not very high, it should be high. Why? Because if the inlet temperature and pressure is high, and to achieve this, for example, let me give you example. For example, if you are admitting your air at 1 bar pressure and your final is around 20 bar, so you have to work between 1 to 20 bar. But as your inlet pressure is 5 bar and you have to achieve 20 bar, so your pressure difference is only 15 bar. Okay, so in diesel engine, we are likely to increase the compression ratio and increase the temperature and pressure to complete combustion of the diesel. So that's why we have to use the inlet high temperature and inlet high pressure as much as possible. The combustion chamber temperature, it should be also high, as I've earlier explained you. Why? Because there are some tiny droplets which is in form of residue, it will be got stuck on the inner cylinder wall. Okay, so if the combustion chamber temperature is high, so that deposited diesel particle, it may get combusted in the next cycle. Okay, then rpm should be low. Why here rpm should be low, engine speed should be low? because because here engine speed should be low, because for maximum compression you have to go very slowly. If you go rapidly, then your combustion could not get properly, that the mixture that is formed by air, it will be not proper, the turbulence that we want to create is not get. Engine size should be small, yes. uh, to achieve all this parameter, for high pressure and the low delay period, high compression ratio, engine size should be small, so that we can achieve in very effective manner. Citan rating is very high, we will talk at the end, because before first that we will discuss these two, supercharging and injection angle advance. So supercharging is what, as I earlier explained you, the density and the velocity of air is increased, so that density increase, so the pressure increase. So for example, if you are before supercharging, if you are entering 1 bar, but now you are entering air at 5 bar, so this will be helpful in the final achieving the final hour compression, final pressure. Then injection angle advance. What is injection angle advance? that is your injection angle. So before the completion of your actual compression process, your fuel, okay, the fuel injector will be opened and it will start to drop down these droplets of diesel. So what happened, some droplets initially get in contact, so it might get burned, and those who are not burned, they come with contact with the air, and they simultaneously get compressed. Okay, so as it compress, its pressure increase, so its temperature increase, and there is a chance to complete combustion to avoid these residues. Okay, clear. Now there is a cetan rating. What is a cetan? As we are talked the octane rating. Okay, there is a cetan rating in the diesel engine. So cetan is what, in a diesel engine there are basically, sorry, in diesel engine there are basically two chemical that will, the percentage proposition will determine the how much cetan rating, and it is same, it is given between 0 to 100. What is cetan? That is normal heptane and alpha methyl butane. Okay, so normal heptane in the cetan. Okay, so this normal heptane has a anti-knock qualities. So it will as a anti-knock quality. So as the proposition in their diesel, the the proposition of this normal heptane is very high. So as their proposition of normal heptane in your diesel is increased, so your cetan rating will increase, and it will try to reduce their knocking in CI engine. Okay, so these are the 10 factors that will affect your knocking, and these 10 factors we can reduce. Hope you guys clear. If you have still any doubt, just ask in the comment section. We will solve your queries in upcoming videos. Okay, so this is all for tomorrow, sorry, today, and tomorrow we will meet with some new questions. Till then, keep studying, stay focused.